All right, in 2.7, we're going to look at inverse functions. Always keep in mind, inverse means opposite operation, not opposite sign. Please try to remember that. That's very important because oftentimes I see students, as we calculate an inverse or find an inverse, sometimes they just change signs, and it's not always positive to negative. Okay, sometimes it is, but not always. So you're truly looking at the opposite operation to where, adding and subtracting are opposites, multiplying and dividing are opposites. Squares and square roots are opposites, things like that. So before we get into all that, let's just look at a term you'll see occasionally in this chapter is one-to-one functions and their inverses. So a function is one-to-one if no y values are repeated. So to be a function, you can't repeat x's. We can repeat y's to be a function, but to be a one-to-one function, that means there's the same number of x's as there are y's. Okay, so no repeating y's. We can determine if a function is one-to-one by using the horizontal line test. So if a horizontal line intersects a graph more than one time, that should be more. I don't know how that went away. Then the function, is one-to-one. So if it intersects it more than once, it's not one-to-one. So this one here is one-to-one. This one here is not, because the horizontal line intersects it twice. Okay, so that one is one-to-one. The other one is not. So let's move on now to actually finding the inverse. There are three ways that we're going to be looking at finding an inverse. Excuse me. One is from points on a graph. Another is from a graph itself. And then the other is from an equation. So always keep in mind, too, that the notation f with that -1 up high as a subscript, or excuse me, a superscript, indicates the inverse. So to find an inverse from points, we reverse the coordinates. Okay? So if this is f, my inverse is going to be 3, 2, 4, -1, -8, 5. I did not change signs. I reversed the coordinates. So please, don't just change signs. Reverse the coordinates. You're interchanging x and y. Now, from a graph, we're going to do similarly to what we just did, except first we have to find the coordinates that are plotted if it's a graph that looks like this, and then reverse them. So if you look at these points here, this one is 1, 2. This one here is 0, 2. And this one here is -3, 0. So the inverse would be 2, 0, 2, 1, 0, -3. So I plot 2, 0, 2, 1, and then 0, -3. Now this is not itself is not a function because I did repeat x's and it's not one-to-one, but it's more so just to illustrate, the process. So you are reversing your coordinates from what you have to get the inverse and then plotting them. Okay, so it's not a one-to-one, it's not even a function, but it's more of just an illustration on what you're supposed to be doing. Okay, so to again find the inverse from a graph, we can also be given an equation to graph, and then we want to find the inverse from it. So I want to graph the original function. I want to find the inverse of the graph using the points from the original graph. You don't need to find the inverse equation to find the graph. And then we want to check for symmetry. So if I want to find the inverse of this graph and I want to graph both of them on the same set of axes, f of 2x minus 3, we can use several of the methods we've learned to graph. You can always pick just any two x's you want. If x is 0, y is negative 3. If x is 1, 2 times 1 is 2, minus 3 is negative 1. So I plot 1, negative 1. I plot 0, negative 3. And then I draw the line. So now what I need to do is I need to graph the inverse. Again, I don't need the equation. All I need to do is reverse these coordinates. So in my XY table, I reverse the coordinates, plot them. Negative 3, 0 is here. Negative 1, 1 is here. So this line goes through there. The line y equals x goes through the origin, and the lines we've drawn should be symmetrical about the line y equals x. That's how you can check to see if you've graphed them correctly, and you can kind of see these are equidistant. They cross. You know, my line's not perfect, but I can kind of tell from here that I'm pretty good. Okay, so when you're finding an inverse from a graph that you're asked to actually draw, you know, find your points that we've learned how to find previously, and then reverse the coordinates. You don't need to find the inverse equation. Now we're going to do that next. Lastly, this is the third way to find our inverse, is from an equation. You know, here are the steps, the process to do it. The reason why we follow these steps here, where we change f of x to y, it allows us to do solving and manipulating. We interchange x and y just so we can have an equation that ends up with an x. Okay, so there's several reasons why we do this. Now, sometimes you might be able to see the inverse. Okay, so I'm going to do it by the steps, but if you think about, you know, doing the opposite of what's being done here, the opposite of 3 times x minus 2 is to add 2, then divide by 3, okay, which is what these steps here are going to allow us to do. So step 1, I change f of x to y. Step 2, I interchange x and y. So see, now I'm going to solve for y, which is going to do what I just talked about, adding 2, dividing by 3. So step 3, solve for y. I'm just going to flip-flop my sides. I add 2, divide by 3. So I get y is x plus 2 over 3. So f inverse of x is x plus 2 over 3. So again, sometimes, you know, you may be pretty good at looking at an equation, figuring out what the inverse is, but other times you may need to learn the process. Sometimes when we do other operations, like with powers or roots or something, it may be helpful to learn these steps. So if I want to find the inverse for f of x is x squared minus 5, step 1, rewrite it. Y equals x squared minus 5. Interchange x and y. So I keep the square there. I'm just interchanging the variables. Then solve for y. So I'm going to add 5 take the square root of both sides. And we don't worry about plus and minus here. Okay, this is just the process we're using to get to the inverse. So f inverse of x here is the square root of x plus 5. Okay, so again, remember, inverse is not opposite sign, it's opposite operation. Opposite of squaring, square root. Okay, opposite of subtracting is adding. Opposite of multiplying is dividing. So just try to remember that and keep that in mind as you're doing the inverse. All right, so that's it. It was a lot, I know, for this next class, but hopefully we'll be all right.